Hey everyone, Mr. Skellin here, back at it for lesson 3 of unit 6, I believe this is. So lesson 3 of unit 6. We're going to be spending close to a week on lesson 3 and lesson 4. A lot of vocabulary words here coming at you in the next few days. We're going to stretch this out a little bit because it is kind of challenging and there's a lot of vocabulary that you got to keep on top of. So I'm going to do my best to let you know what those vocab words are, what they mean, what they look like, and how you can apply them, okay? So what we're going to be talking about in these next few lessons are different types of lines within triangles, okay? And so the first vocab word is concurrent lines, and that just means when two or more lines, I'll put lines in quotation marks because you're going to find out that they could be perpendicular bisectors, angle bisectors. These are all types of lines that could be happening inside of the triangle. So when two or more lines intersect, okay? And there's a vocab word that I didn't put on here. I'm going to say point of concurrency. I'm going to underline that one. And point of concurrency is the point where the two or more lines meet. Okay? So if we're doing vocab words here, this is vocab word number 1. This is vocab word number 2. And you can kind of keep track here. I'll kind of keep track on the side. So concurrent lines are when two or more lines intersect, and the point of concurrency is actually where they meet, and I'll keep referring to them. So the first thing we want to do on this triangle here is you're going to need your contractor. So if you need to hit pause and find that, go for it. And it says to construct the perpendicular bisectors of the two sides of the triangle. So this is good review for your contractor work here. I'm going to pick 60. Remember, when we're doing perpendicular bisectors, you want to pick a dot that's more than halfway. So I'm going to pick 60. Okay? And I'm just going to make a slash up here for 60, and then I'm going to do it back down here. I may just keep it up at the top here. And then I'm going to flip my contractor over, and I'm going to find 60 again, which was up here. And I'm going to make that swoop for 60. I may get into my vocab words down here. I hope I don't. 60 there, and then 60 again. I know I'm kind of all over the place here with you. And then 60. Oops. I should have picked a different side. Let's see, back to 60. Where'd you go, 60? There you are. Okay, so cutting this side in half. Made a little mess of it. That's okay. And you take your contractor, get the straight edge part, all right? And we're going right through those points there. Okay, and I'm going to do it to one more side. I'm actually going to I'm going to cut this side in half here. So I'm going to do the same thing. Contractor there, pick a point. I'm going to pick 40 this time. And 40 there, 40 up top. Okay, and then underneath it, so 40 here, and then 40 on this side. And a line straight through. Okay, and you get something like that. So the directions after all that, and hopefully that was okay for you, it says construct the perpendicular bisector of two sides, which I did. I just bisected this left side here, and I just bisected the bottom side here. And you can quickly check. I mean, just from this corner 0, close to 3, and it's close to 3. I'm right on target. Now, the point of concurrency of the perpendicular, I'll use black here not to be confused, perpendicular bisectors is called the circumcenter. This is vocab word number 3. Okay, the circumcenter is this point right here. This is where those perpendicular bisectors came together, right there, all right? And that's important. That's called the circumcenter. So that what you need to have connected in your thoughts is perpendicular bisectors meet at the circumcenter. Okay? Perpendicular bisectors meet at what's called the circumcenter. Now, there is something very important about the circumcenter of a triangle. And the circumcenter is the same distance from the vertices, which is, remember, that just means the corners, the vertices of the triangle. So I don't have my straight, I have my straight edge, but if you took, and if I put like little dots here, which represents the vertices of the corners, you take your straight edge and you measure from here, it's about 5 inches there. It should be the same, 5 inches there and 5 inches there. Perfect. Whoop, I'm off the paper. Sorry. From this corner is 0 to 5 inches to the circumcenter. I go to this corner, it's 0, 5 inches there. And if I go to this corner over here, it's 0 to 5 inches. The distance from the circumcenter to each of these dots is exactly the same, and that's the purpose of the circumcenter. Okay? That's what I just stated right here. The circumcenter is the same distance from all the corners. So down at the bottom here, it says a circle is circumscribed about. We say circumscribed about. Now, circumscribed is your fourth vocabulary word. This is number 4, which you have to know. Okay? And basically, circumscribed means a circle outside or around the triangle. If you circumscribe something, it goes outside or around something. That's what circumscribed means. So if I said to define circumscribed, you'd say drawing a circle outside or around a circle, or around a triangle. So over here is just a quick diagram, again, of what that kind of looks like. So you can see right here, and this is where you kind of have to connect everything. You have to look at this triangle, and you have to notice all these perpendicular bisectors. You have to look at this picture and say, okay, that's a perpendicular bisector, 90 degrees, cutting the side in half. That's a perpendicular bisector, 90 degrees, cutting this side in half. That's a perpendicular bisector, cutting that side in half. So you have to know that these are all perpendicular bisectors, and then here is what I stated with this right here, that the circumcenter is the same distance to all the corners. And so we would say circumscribed here. This is a circumscribed circle because it's around the outside. And this point right here where all the perpendicular bisectors meet, again, this is review, is the circumcenter. Okay? Now, why do we, what's the point of this, right? You're probably wondering, oh great, what's the point of this? Well, honestly, in design, like if you're a city planner, okay, or you're a park designer, and you're making a city park for somebody, and you have, for example, I'm just going to make a quick and dirty example here. Let's say you have a playground here, okay, and you have a water splash pad over here, and you have, I don't know, food over here, a food station, okay? And you, as a city planner, you want to put a picnic table, or you want to put a gathering place right in the middle of all 3 of these. So I'll put a dot here for the playground, here's a dot that represents the water station, and here's a dot that represents the food. And your job as a city planner is to place a picnic table or picnic tables or a seating station for people to sit at right in the middle of all 3 of these, so you can kind of be in the center of the action. The question would be, what type of point of concurrency would you want? Well, these 3 points would make a triangle, and if we want it right exactly in the middle, we just talked about that the circumcenter is in the middle of all 3 corners. We just measured it up here. So that's why we use what's called the circumcenter, because it's right in the middle. All these distances from here to here to here are all going to be the same. Okay? All right, on the back, we're going to talk about a second type of line. So on the front, we just got done talking about perpendicular bisectors. inside of a triangle. Now we're going to be talking about angle bisectors inside of a triangle. So the first thing we need to do is construct angle bisectors. So let's review that real quick. I'm just going to pick 40. If you remember, we just make a big swoop, okay? And then we got to put our brass circles there, and I'll just use 40 again, and I'll put one out in front here, 40 again down here. Okay, take my straight edge from the corner all the way through. Okay, there's one angle bisector, and then I'll do this corner down here. So I'll pick 40 again, just because it's easy. 40. I'll pick 40 again over here. Just got to kind of keep your lines in order. And straight edge. And so I've bisected two angles. Now, what we want to do is we want to find, I'm going to probably do this in blue here. I'm going to put the actual bisector in blue so that you can see where they actually meet here, so you don't get too confused with all the markings, because we want to see where the angle bisectors are meeting. So basically you want to see where those blue lines intersect, which is right here, right there, okay? This is, let's see, what vocabulary word are we on? We're on, that was the fourth one there, so we're on vocab word 5. So this is vocab word 5. This is called the incenter. Where your angle bisectors meet is called the incenter. This point right here, where your angle bisectors in blue meet, that point right there is called the incenter, okay? And that has some properties just like what we did on the front. We're going to talk about those next. So our point of concurrency of the angle bisectors is called the incenter. That's vocab word 5. Now, what's special about the incenter? The incenter is the same distance from the sides of the triangle, okay? So with angle bisectors, a circle is inscribed about a polygon. So if you look at this visual here, do you see that your circle is on the inside as opposed to on the other side? It was around it. So inscribed is your 6th vocabulary word. And what does inscribed mean to you? It should mean that a circle inside is the key word, inside of a triangle. So inscribed means inside, pretty easy to remember. I-N, I-N, in and in. So this is an inscribed circle. And you have to look at this picture, because I could give you this picture on a quiz and say, okay, what is this point? And you would have to notice that these are all angle bisectors meeting at this point. And so that would be the incenter. Okay? Now, why do we use the incenter? Just like on the front side, I gave you a quick example about why we would use the circumcenter. Well, it all comes back to this. The incenter is the same distance from all the sides. So if you look at this picture down here, this statement is the big statement. Xi is equal to yi, which is equal to zi. So this point, right in the middle, the incenter, is equal distance from the sides of the triangle. As opposed to, on the front side, the circumcenter is equal distance to all the corners. Okay, so it's a little different. QC, this, is equal to this, which is equal to this, those distances to the corners. Confusing, but just got to practice and learn it. Now, why would we do this? What would we use in the real world to kind of describe or apply to an incenter? So everybody's probably been on a road trip before, right? So let's envision I-69, which runs north and south here, right? I-69 runs north and south through the great state of Indiana. and let's say we're going north, like we're going to Michigan, or we want to jump on, there's a national highway called 8090. So let's make this, all right, 8090. 8090 actually runs, I believe, all the way from the East Coast to the West Coast. And what is it? There's a road that goes to Toledo, and I can't think of it off the top of my head right now, but let's say there's a road over here by Ohio that's going this way. All right, like runs up to Toledo. We'll call it Ohio 1. I don't know. Okay. And so, obviously, I've made a triangle. This isn't perfect, but the purpose of putting an in-center is to create like a rest stop that could be used for all the highways. Okay. So we wanted to, as a planner, put a rest stop that's in the middle of all 3 highways. So we'd want to put them equal distance from the sides, not the corners. Those are my tick marks to say that they're equal to each other, not plus signs. I'm saying this distance and this distance and this distance are all the same. The rest stop would be an example of an in-center because it's in the middle of all the sides as opposed to your picnic table being from the corners. Okay, so that's the difference between them. All right, so we're just kind of getting started here. Got 6 vocabulary words for you. I know that's a lot in one lesson, but you got to practice those, and it's going to be really, really helpful if you can get to know these pictures and what they mean and what they look like, so that you can recognize some of those vocab words. All right, we'll get back at it in class on the assignment. If you have questions, let me know.